Hello students, in this video I'm going to revise the chapter polynomials. In this chapter first you need to learn the definition of what a polynomial. I have given the general form of the polynomial for you. So just once look at the polynomial. So in that polynomial I told for you, actually I have written p of x, and here x is actually what variable. Okay, x is the variable, but you can choose any variable, either y or z or t. Okay, like that, x is the variable, and in that expression it is actually like this: a n x power n plus a n minus 1 x power n minus 1 plus so on, a 2 x power 2 plus a1 x power 1 plus a naught, like this. This is actually the general form. So here look at the exponent of the variable in each term is actually what type of number. Here it is actually x power 0 is present. X power 0 means 1. So that's why I have not written x power 0 here. X power 0, 1, 2, 3, 4, 5 and so on. Here n minus 1 n. So n is actually what? This is a natural number. Okay. So remember this one. The exponent should be what? Natural number. Okay. If there is any fraction, okay, if there is any fraction or negative number, so then it is not a polynomial. Remember, okay, if there appears any fractional number as an exponent of x, and if there is any negative number as an exponent of x, then it is not a polynomial, because it is the standard form. Okay, exponent of x should be what? It should be natural number including 0. So that's why it is better to say whole number. Okay, instead of natural number it is better to say whole number, or n is non-negative integer. It is also right, non-negative non-negative integer. Non-negative integer means n can take the values 0 1 2 3 4 5 and so on, like this. Okay, now look at here, this is the value of n. Okay, n is equal to 0, n is equal to 1, n is equal to 2, n is equal to 3 and so on. Okay, so this is actually the condition for general form of a polynomial. So the next important definitions under this chapter is very important thing is degree of the polynomial. Okay, so degree, and then coefficients, coefficient of x square, coefficient of x, like that. They are actually very important. I'm going to explain this one by taking an example. Let us consider a polynomial like this: p of x is equal to 3x square minus x plus 10, like this. Okay, now look at here, what is the variable? X is the variable, and if you look at the exponent of the x, it is a non-negative integer. Now look at here, x power 2, x power 1. Here x power 0 is present actually. Okay, 10 into x power 0. So now what is the highest exponent of the variable here? So look at here, in this term the highest exponent is what? 2. So that's why 2 is actually called as what? Degree of the polynomial. Remember, highest exponent of the variable in the given polynomial is called as what? Degree of the polynomial. And coefficient means what? So beside each variable means variable is same x, but in this term, within this term 3x square. Okay, if we treat this one as a one term, in this term along with this one variable, okay, along with this term one number will be present beside the x square. So this number is actually called as what? Coefficient of x square. Okay, coefficient of x square. Suppose this term is just like this: if it is just x square, then nothing is present means 1 is present. Okay, so that's why here 1 will become what? Coefficient of x square, like this. So in the same sense, what is the coefficient of x here? Here it is minus 1. If it is negative, you need to include the negative sign also. So what is the coefficient of x power 0 means, then your answer is actually what? 10, and it is also called as a constant term of the polynomial. Remember this one. If someone asked for you what is the constant term in this polynomial, it is nothing but what? Coefficient of x naught actually. Okay, coefficient of x naught is actually asked for you. So this is also called as a constant term or coefficient of x power 0, like this. Okay, so these are the two important things regarding the polynomials: degree and coefficient. Go through the notes and once again look at the definition and examples, and then it will become very clear for you. Now the next important thing is a zero of a polynomial. So what is zero of a polynomial? Now before that, one thing I forgot to you for you. I forgot to mention for you. So types of polynomial. Okay, I'm going to write down here types of polynomial. So types of polynomial. There are three different types of classification actually. So among the three, only one type will be very important for you. So the classification which is based on degree. Okay, remember this one. This is very important. So based on degree, polynomial can be classified like this. Okay, so if it is of degree 1, called as linear. If it is of degree 2, it is called as what? Quadratic. If it is of degree 3, it is called as cubic. If it is of degree 4, is called as actually what? Biquadratic. Okay, so these are the important types of polynomial. Remember this one. So biquadratic means degree 4, cubic means degree 3. Okay, quadratic means degree 2, and linear means degree 1. If it is of degree 0, okay, so if it is of degree 0, it's actually called as what? Constant polynomial. Remember this one, it is also very important, constant polynomial. And for one more polynomial is there, zero polynomial. Okay, so this is also very important, zero polynomial. So what is the degree of the zero polynomial? It is undefined. Okay, so I have clarified this one for you in the class itself. And the two more types of classifications of polynomials are also there, which is based on number of terms, monomial, binomial, and based on number of variables. So polynomial in one variable, two variable, like that also. But apart from those two, this is very important. Remember this one. Okay, identification of polynomial, degree of the polynomial. If you identify the degree, then you can decide what type of polynomial it is. So next thing is a zero of a polynomial. Just I will explain this one by taking an example. Okay, p of x is equal to 3x plus 2 is a polynomial. What type of polynomial it is? Linear, because degree 1. So now if you place in the place of x, if you place minus 2 by 3, let us see what will happen. Zero of a polynomial. So let us see what will happen if you place in the place of x. If you place minus 2 by 3, then we can denote that one like p of minus 2 by 3, because I'm going to replace x by minus 2 by 3. That's why, which is equal to 3 into x means what? Minus 2 by 3. Okay, minus 2 divided by 3, and then plus 2 actually. Okay, so here 3 and 3 will get cancelled, and then minus 2 and then plus 2 is the remaining. It will become 0. So by this we can say minus 2 by 3 is 0 of this polynomial p of x. So that's why the value of x for which the value of the polynomial p of x becomes 0, it is actually called as what? 0 of a polynomial. And remember, for a linear polynomial you will get 1 0. Okay, so for a quadratic polynomial it is depend upon the degree. Okay, so it will have 1 0, and a quadratic polynomial it will have two zeros. Okay, at most maximum number of zeros. And cubic means it will have three zeros. Biquadratic means it will have four zeros. It is equal to the degree of the polynomial. Remember. Okay, and for a constant of polynomial there are no zeros. Remember, there are no zeros. Okay, for constant polynomial. Okay, so this is actually the first topic of this chapter related to zeros of a polynomial. Next one is a remainder theorem. Okay, what actually it says a remainder theorem? So it's just similar to that of our last one. If you know the knowledge of how to find out the value of a polynomial, so it is actually related to division of a polynomial. So I think you know this one. When you divide a division of a polynomial, when you divide a polynomial p of x by a polynomial g of x, you will get some quotient. Okay, so q of x will be quotient actually, and sometimes you will get a remainder also, r of x, and we can express this one like this: p of x is equal to g of x divisor into q of x quotient, and then plus r of x remainder. So now to find out the remainder, when we divide a polynomial p of x by g of x, one of the advantage is remainder theorem. Without dividing the polynomial p of x by g of x, we can find out what is the remainder. So that is actually remainder theorem, advantage of remainder theorem. So just I will show an example for you. I'm going to consider a polynomial like this. So p of x is equal to x power 4 plus x power 3 minus 2x square plus x plus 1. and g of x is equal to what? X minus 1. Now this is what? Dividend. This is divisor. Okay, I'm going to divide p of x by g of x. Now g of x is what? X minus 1. So now if you equate this one to 0, g of x to 0, we get like this: x minus 1 to 0, because g of x is equal to x minus 1. That's why x minus 1 is equal to 0. Then x will become what? 1. So now you need to place 1 in the place of x, because we got x is equal to 1, and I'm going to find out what is p of 1 actually. 1 power 4 plus 1 power 3 minus 2 into 1 power 2 plus x means 1 plus last 1 is present as it is. Now if you simplify this one, 1 power 4 means 1, 1 power 3 means 1, 1 square means 1, 1 into minus 2 means minus 2, and then plus here it is 1, and here it is last 1 is there 1. Okay, so 1 plus 1 it will become 2, and it will get cancelled with minus 2. What is the remaining thing? Just 2. So this is actually what? A remainder. Okay, so this will be the remainder when you divide p of x by the g of x. You can do this one by division algorithm also. If you divide polynomial p of x by g of x, finally you will get a remainder is equal to 2. Okay, so this is actually without dividing the polynomial p of x, I have found out what is the remainder when you divide p of x by g of x. Next one is factor theorem. This is actually the extended format of what? Remainder theorem. If you know the remainder theorem, then it will little bit very easy. Okay, only one step. So factor theorem means, let us suppose you are going to divide p of x by the polynomial g of x. If you get remainder r of x equal to 0, not quotient. Okay, so whatever may be the quotient, it's actually non-zero. Okay, so but if the remainder becomes a 0, then g is called as a factor of p of x. Remember, okay, g will become what? A factor. So if it is not equal to 0, just it is a divisor. If remainder becomes 0, then g of x is actually called as what? Factor of p of x. Okay, so now how to verify whether g of x is factor of p of x or not? Okay, for the same question. Okay, now for this question I'm going to say like this: here p of x is the polynomial, g of x is the divisor. I'm going to divide p of x by g of x, and I have found out remainder is actually what? 2. It is actually what? Non-zero. Remainder is non-zero means g of x is not a factor of p of x. Okay, so just by verifying what is actually a remainder, we can decide whether g of x is factor of p of x or not. Okay, I'm not going to divide here, but without division, I'm going to find out what is the remainder by remainder theorem. If it is 0, remainder 0, then g of x is factor of p of x. If it is not 0, then it is not a factor of g of x, p of x. Okay, it's just divisor actually. Okay, now I will consider an example for a factor. Okay, so from your textbook, I'm going to take an example. So now let us consider p of x is equal to like this, g of x is equal to like this, similar to that of previous one. Now if you equate g of x to 0, so here it is once again this here it actually x minus 1, but here it is x plus 1. X plus 1 becomes 0. X is equal to what? Minus 1. Okay, now you need to place minus 1 in the place of x here. So that's why it will become p of minus 1. Now let us see what will be the answer for this one. If it is a 0, then g of x is factor of p of x. If it is non-zero, then not a factor. Okay, so now look at here, minus 1 whole power 3. So negative is that, that's why it is better to put the bracket. Okay, you must put the bracket. And then next, plus of x square means minus 1 whole square, plus of minus 1. Okay, and then plus 1. Okay, x minus 1. So minus 1 whole cube means what? Minus 1. Minus 1 whole square means it will become plus 1. Plus into minus, minus 1, and the last one is plus 1. Now minus 1 plus 1 will get cancelled. Minus 1 plus 1 will get cancelled. Answer 0. So this is actually what it indicates: remainder is 0. When you divide p of x by g of x, remainder becomes 0, means g of x is actually what? A factor of p of x. Okay, g of x is actually what? Factor of p of x. This is actually what? Factor theorem. Okay, a little bit same actually, remainder and factor theorem. Whatever the technique we are going to use in a remainder theorem to find out the remainder, the same thing I'm going to use here, but I'm going to verify whether it is 0 or non-zero. If a remainder is 0, factor. Remainder non-zero, it's not a factor. So the last thing of this chapter is actually what related to algebraic identities. In algebraic identities you need to remember all the identities. Okay, so I think I have listed already all the identities. So just actually all the problems are based on the identities only. X plus a into x plus b, and next one is x plus y into x minus y, and then next third one is x plus y whole square, and then x minus y whole square, and then x plus y whole cube, x minus y whole cube. Okay, and then x cube plus y cube, and then x cube minus y cube. Okay, and actually one more x cube plus y cube plus z cube minus 3xyz is equal to, it is actually one of the identity, but actually problems are deleted based on this identity actually. If you want you can look at this one also, but the question will not be asked based on these identities. So just you need to learn all these identities. Okay, so only two types of problem will be asked. So simplification, okay, simplify using identity, or else it will be like this factorization. Okay, so two types of problem will be asked for you. One is related to factorization, or another one just you need to, he will ask to simplify by using the algebraic identity. Okay, so then you need to apply the formula for these things. Okay, so apply the identity here. Okay, apply identity. So but in the factorization case, the RHS of all these formulas will be given to you. Okay, so it's actually in the form of right hand side of the algebraic identities, and you need to convert this one into what, left hand side. Okay, so like this. Okay, x plus y whole square, x plus y whole cube, x cube plus y cube, like that you need to convert this one. If you know these identities, then you can do all the problems, and all the problems are actually very simple. Okay, just you can identify which is the suitable identity to solve this one, and this will be asked only for, if it is a very simple question, it may ask for 1 mark also, even in 1 mark. But if it is somewhat a little bit lengthy, it will be asked for 2 mark only. Okay, so the maximum number of marks may be around 2 marks, but some questions are actually asked based on this one for 3 marks, but in this year it is actually deleted for you. So that's why in the algebraic identity heading, the question will appear for 2 marks. Okay, each question may carry 2 marks. That's why the question will appear around 2 marks. If two sub questions are given to you, okay, so two sub question, then it will make 4 marks. Okay, two for this one, two for this one, like this. So that's why two marks combine ಮಾಡಿ 4 mark ಬರ್ಬೋದು, or around 2 marks ಬರ್ಬೋದು. And then factor theorem ಮೇಲೆ ನಿಮಗೆ ರಿಮೈಂಡರ್ ಥಿಯರಮ್ ಮೇಲೆ, ಸೊ ಅದು ಕೂಡ 2 marks ಕ್ವಶನ್ ಆಗುತ್ತೆ, ಫ್ಯಾಕ್ಟರ್ ಥಿಯರಮ್ ಅಂಡ್ ದೆನ್ ವಾಟ್ ರಿಮೈಂಡರ್ ಥಿಯರಮ್. 2 marks ಗೆ ಮ್ಯಾಕ್ಸಿಮಮ್, ಈವನ್ 1 mark ಅಲ್ಲೂ ಕೂಡ ಅಪಿಯರ್ ಆದ್ರೂ ಕೂಡ ಆಗ್ಬೋದು. Okay, so and then based on degree identification, and then coefficient identification, like that, finding value of a polynomial, and then finding the zeros of a polynomial. So these are actually 1 mark questions. Okay, so that's why maximum is actually in this chapter. In the last section, if it is combined like this, it will take 4 marks, or otherwise if one question is asked only for 2 mark, factor theorem, reminder theorem, these are all 2 mark question for you. So that's why you need to it's very simple, just the number of problems is more on this heading. Okay, if you cover all these problems under the heading algebraic identity, so this almost all completes the chapter algebraic identity. And the third chapter, it is actually coordinate geometry. It is a very simple chapter. I think everything is very perfect for you. Just identification of a position of point when coordinates are given to you. And the second type of problems are actually a graph will be given to you, points will be located in the graph sheet, you need to identify what are the coordinates, or else coordinates will be given to you and you need to identify the position on the graph sheet. ಸೊ ಕಾರ್ಟಿಷಿಯನ್ ಕೋಆರ್ಡಿನೇಟ್ ಸಿಸ್ಟಮ್ ಒಳಗಡೆ ಪೊಸಿಷನ್ ಐಡೆಂಟಿಫೈ ಮಾಡ್ಲಿಕ್ಕೆ ನಿಮಗೆ ಕ್ಲಿಯರ್ ಆಗಿ ಗೊತ್ತಾಗಿದೆ ಅದು ಹೇಗೆ ಫೈಂಡ್ ಔಟ್ ಮಾಡೋದು. ಕೋಆರ್ಡಿನೇಟ್ಸ್ ನಾನು ಕೊಟ್ಟರೆ ಅದರ ಪೊಸಿಷನ್ ಎಲ್ಲಿದೆ ಹೇಳೋದು, ಅಥವಾ ಪೊಸಿಷನ್ ನಾನೇ ಗ್ರಾಫ್ ಅಲ್ಲಿ ಮಾರ್ಕ್ ಮಾಡಿದ್ರೆ ಅದರ ಕೋಆರ್ಡಿನೇಟ್ಸ್ ಏನು ಅಂತ ಹೇಳೋದು. ಇಷ್ಟು ಬಿಟ್ರೆ ಇನ್ನೇನು ಇಲ್ಲ ಆ ಚಾಪ್ಟರ್ ಅಲ್ಲಿ. ಸೊ ಇದೆಲ್ಲ ಗೊತ್ತಿದೆ. ಅಂಡ್ ದೆನ್ ಬೇಸಿಕ್ಸ್ ನೋಡ್ಕೊಳ್ಳಿ. ಕಾರ್ಟೇಶಿಯನ್ ಕೋಆರ್ಡಿನೇಟ್ ಸಿಸ್ಟಮ್ ಅಲ್ಲಿ ನಾನು ಏನು ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿದ್ದೀನಲ್ವಾ. ಸೊ ಎಕ್ಸ್ ಆಕ್ಸಿಸ್, ವೈ ಆಕ್ಸಿಸ್, ಹಾರಿಜಾಂಟಲ್ ಲೈನ್, ವರ್ಟಿಕಲ್ ಲೈನ್, ಆರಿಜಿನ್, what is origin, axis or ordinate. So it's also called as x coordinate, y coordinate, axis ordinate, and the sign of the coordinates in different quadrants, and general form of a point when it lies on x axis, y axis, like this. ಇದೆಲ್ಲ 1 ಮಾರ್ಕ್ ಕ್ವಶನ್ ಆಗುತ್ತೆ. ಇದೆಲ್ಲ ನೋಡ್ಕೊಂಡ್ರೆ ಇದೆಲ್ಲ 1 ಮಾರ್ಕ್ ಅಲ್ಲಿ ಆಗುತ್ತೆ, ಅವ್ರ MCQ ಅದರಲ್ಲಿ ಕೇಳ್ಬೋದು ನಿಮಗೆ. ಓಕೆ, ಸೊ ಇದಿಷ್ಟು ಬಿಟ್ರೆ ಇನ್ನ ಗ್ರಾಫ್ ರಿಲೇಟೆಡ್ ಇಲ್ಲಿ ಒಂದು ಗ್ರಾಫ್ ಕ್ವಶನ್ ನಿಮಗೆ ನಾನೇ ಗ್ರಾಫ್ ಅಲ್ಲಿ ಪೊಸಿಷನ್ ಕೊಟ್ಬಿಟ್ರೆ, ಸೊ ಜಸ್ಟ್ ಪೊಸಿಷನ್ ಡಿಫೈನ್ ಮಾಡಬೇಕಾಗುತ್ತೆ ಅಷ್ಟೇ ನೀವು. ಗ್ರಾಫ್ ಶೀಟ್ ನಾಟ್ ನೆಸೆಸರಿ, ಬಟ್ ಇಫ್ ಐ ಗಿವ್ ದ ಕೋಆರ್ಡಿನೇಟ್ಸ್ ಫಾರ್ ಯು and if I ask you to locate these points on the graph sheet means then you need to graph sheet actually. Okay, graph sheet requirement ಇರುತ್ತೆ ಸೊ ಒಟ್ನಲ್ಲಿ. ಸೊ ಗ್ರಾಫ್ ಶೀಟ್ ಇಟ್ಕೋಬೇಕಾಗುತ್ತೆ ನಾಳೆ ನೀವು ಎಕ್ಸಾಮ್ಗೆ. ಓಕೆ, ಸೊ ಮೀನ್ಸ್ ನಾಳೆ ಇನ್ ದ ಸೆನ್ಸ್ next day actually. Okay, so then of for remaining chapters, I'm not going to revise the remaining chapters because the complete chapter is actually in my playlist. Okay, if you go through the playlist you will get the complete lecture for you. Okay, complete classes are already in the playlist. You can go and again watch all those uh, problems, whatever you want. Okay, so then tomorrow I'm going to clarify for you if you have any doubts. Okay, then I told for you for the first second chapter have made a revision classes for you. I think it will be beneficial for you, and try to cover all the syllabus. Okay, don't forget, don't leave anything, because it will be helpful for your main exam also. If you cover all the 5 chapters, you will become thorough in the 5 chapters, and it will be beneficial for main examination also. Okay, so tomorrow I'm going to clarify if you have any doubts, and today I'm going to wind up this class. Thank you one and all.